Welcome back. Today I am super excited. We're going to be playing with lasers, diode lasers, CO2 lasers, and fiber lasers. We're going to compare them, we're going to see what's different about each of them, and which one you should probably get for the job you want to do. Let's jump into it. Lasers. I friggin' love lasers. There's just something kind of magical to me about the fact that you're using just light to engrave or cut something. It's just incredible. They're super fast, they're super easy, and the prices have been dropping like crazy for the last few years. Now before we get into comparing all these different types of lasers, let's get the disclaimers out of the way first. First off, this video is sponsored by Lightburn Software. They don't make a laser, they make software for controlling lasers. I have heard for ages from people in the community, if I'm gonna get a laser, I should check out Lightburn as an upgrade. I did, I checked it out, it was awesome. I reached out to them and they agreed to sponsor this video. So we'll get more into them later and why you should check out Lightburn. The next disclaimer is safety. Lasers are dangerous to your eyes. Inevitably, anytime that we have a laser video, somebody points out you need to have eye protection. Yes, you need eye protection. Protect your eyes from lasers. Get the proper glasses that you need to protect your eyes from the lasers, and always wear it when you're operating them. Don't operate them out in the open in public. And then the final disclaimer, I'm going to be saying a lot of things that are generalities. Things like a fiber laser uses a galvo head. If you're familiar with lasers, you know that there are gantry-based fiber lasers, and there's galvo-based CO2 lasers. These are basic generalities that you're going to see on the desktop. So just know that what I'm talking about are kind of generalizations, and you should definitely do a little bit more research before you actually purchase a laser. Hopefully, though, I'll be able to give you some information that will help you sort out what you need to research and which laser you should be looking at. In this video, we're going to be looking at the three main types of lasers: a diode laser, a CO2 laser, and a fiber laser. I'm going to take you through what each one of them is, how they're different, compare some of the main aspects of each of them, and so that way maybe you can decide which you need to look at. Let's start with the diode. This is a diode laser. You can recognize these generally because they are an open gantry like this. They don't have an enclosure around them, though admittedly there are a few out there that have built a box around their system. The easiest way to identify a diode laser is this. This is the entire laser unit right here. The rest is just control and motion. Let's start with the pros. They're relatively cheap. You can get a diode laser for anywhere from $200 and then upwards to, $600 or $700. I've even seen one marketed at $3,000 for a diode laser. Being relatively cheap is a huge plus. It's a lot of people's entry point into laser engraving and laser cutting. Another upside is that this little open gantry system here and simple laser mean that it's very small and portable. I can throw it in the car, I can take it somewhere to do some cutting that needs to be done outside of my workshop. Of course, be sure to follow safety protocols. You don't want to be hurting people's eyes out in public with these. I can move it to different areas of my house. I can position it on a larger piece of material. For example, this workbench, if I wanted to engrave a logo right here in the middle, this would be a great tool for that. I could just put it right here and engrave it. That's pretty cool. Another upside is the easy upgrade path. The laser module, just being a single piece here that you can take off, means you can buy a more powerful one to throw on there. And there are many available on the market. They generally are somewhat interchangeable, which is nice. Now you, of course, will need to research what you have and what you're wanting to plug into it to make sure it can power it and control it. But the general concept is pretty cool. Another cool thing, now this one ties into our sponsor, Lightburn. One cool thing that I love about diode lasers is the fact that since they're portable, you can engrave something really big if you have software that can help you do that. Lightburn has a feature which allows you to cut up a large image and then engrave it in different pieces and parts and move your laser around and line it all up perfectly. I think that's awesome. And in my opinion, that feature alone makes diode lasers much more valuable. If you've purchased a laser of any kind in the last 10 years or so, you know that what you get to control it with is pretty outdated and ugly. Lightburn is here to solve that. It is up-to-date control software for lasers. It works on G-code lasers, DSP lasers, and soon there's even going to be a version for Galvo lasers. What that basically means is Lightburn will probably work on any laser you get, from cheap to expensive. There's an active community. They're constantly updating it, and it has features that are really, really nice when working with the laser. There's things like the fact that you can drag and drop into Lightburn from almost anything. You can drag and drop from a web browser, which is fantastic. The image trace tool is much better than the other tools I've used. The interface is prettier. It's actually anti-aliased, which seems like a tiny thing, but when you're zooming in to work on laser paths, that nice, smooth, crisp image is important. There is a preview which lets you actually see how your laser is going to be moving. And my favorite feature, the one you're seeing in the time lapse above, is the fact that you can use a dirt cheap diode laser to do massive engravings that are bigger than the area of the laser. Lightburn is cross-platform. It works in Windows, Mac, Linux, and if you really wanted to show off what you're doing, or if you have problems, there's an active forum where people are sharing tips, tricks, and showing off what they've made. You can give Lightburn a 30-day trial absolutely for free with no restrictions. There's a link for that down below. Diode lasers are somewhat weak when compared to a C02 laser or a fiber laser. Now, like I mentioned, laser wattage is a tough thing to use as an example, but it's really the only number we have. One thing you need to be fully aware of, though, the nasty habit we've been seeing coming out of diode laser companies, is the fact that they will market a machine such as this as a 50-watt machine, but that's including the power supply in all of that, when actually the diode laser for a 50-watt machine might only be 6 watts or 10 watts or 15 at most or something like that. It is a nasty habit. We hope they stop doing it because it is misleading. All right, let's check out C02 lasers. This is a C02 laser. C02 lasers are generally easy to identify or to recognize because they have a large laser tube. In this case, it's a glass tube. Sometimes it's encased in metal, so it just looks like a big metal rectangle. But the point is, the laser shoots out of that, hits some mirrors, and goes to the cutting head where it's directed down at the material. Most of the CO2 lasers you're going to see are big boxes that have a gantry inside of them. If you look in there and you see mirrors that are aiming the laser around, it's generally a CO2 laser. This particular model, except for an upgrade here, is what you would consider to be probably the cheapest CO2 laser you can get. This is called a K40. You can just search for it. A lot of different manufacturers make them, and you can find them anywhere from $350 to $600 for a basic kit of a K40. There's no specific manufacturer that you need to look for. There are a bunch of them out there, and they all kind of have very similar effects. It's a 30 or 40 watt laser tube. It's got a gantry inside with rails, sometimes linear rails for motion, and you're going to need water cooling to go with them. In the case of these, it's just a simple pump inside of a bucket of water. Also, air assist is very important to get nice clean cuts. The pros and cons of a CO2 laser. Well, CO2 lasers are much more powerful than a diode laser, and so you're going to be able to do everything faster. You're going to be able to engrave faster and cut faster. Not only are they more powerful, but in most cases they have larger motors and a more rigid system, which allows them to move faster physically. So the ability to move faster combined with a stronger laser means that you'll be able to engrave things much, much quicker. It can be much more time efficient. The cost, for something like this being around, let's say, $400, is kind of in the middle of the range of what I was saying earlier, puts it about the same cost as a more expensive diode laser. So that makes the decision a little bit more difficult. However, the prices rise quickly from there into the thousands. So if you look at something like a Glowforge, a Muse, or the Dremel laser, those are all going to be in the $3,000 to $6,000 range for a machine that is very similar to this, but with much more polish and a few features that would be nice, but similar in power and speed. Some of the cons of a C02 laser are, of course, the price. When you get up into the thousands and thousands of dollars, it gets kind of hard to justify sometimes. You know, you need extra accessories to go with them, like the water bucket or a chiller, and, you know, air assist as well. The size can be an issue. The overall size of the machine, as you can see, this thing has a very similar cut size area to the diode laser that I use, but it's this huge box and a bucket and an air pump, so the size can make a difference. And this is actually a small CO2 laser. Once you start going up into bigger ones, it's a much bigger machine, as big as these two workbenches that I have here together. And then the cut area is limited. For example, this one cuts about the size of a sheet of printer paper. For this whole box, that's the biggest it cuts. And this one does not have a pass-through. So you cannot put pieces through and move them around and cut different sizes. So you're limited with this machine to only about the size of a sheet of paper. The laser tube in these is considered a consumable. The lifetime of these is generally measured in hours, thousands of hours. So the more you use it, the faster it's going to run out, and you're going to have to buy a new laser tube for your machine. Those are the basics of a CO2 laser cutter. Let's move on to fiber. This is a fiber laser, and these are very interesting. Their primary use is engraving and cutting metal. Although with this 20-watt fiber laser, you won't be doing much cutting. You can do some engraving though, which is really cool. It's very hard to compare a fiber laser with a galvo head to a CO2 laser or a diode laser because they're really different uses. And this is where saying the power, the wattage, gets really complicated, because this is only a 20-watt laser. So it's technically not as strong as like the CO2 laser. But this laser can engrave metal and the CO2 laser can't. So it's not just about power. The pros of a fiber laser. Well, the biggest pro to a fiber laser is the fact that you can engrave metal. You can't do that on the others. You can actually engrave into metal. You'll recognize these typically because they use a galvo head. That is a set of mirrors that reflects the light. Your laser engine is down in here. It comes through a fiber optic cable out to the galvo head, and it's reflected down onto the surface here. That allows them to move very quickly. You can see some examples whenever it comes to engraving. These are very fast. Even this, which is, like I said, this is a 20 watt. This is kind of the lowest power wattage you can get for a fiber laser. Even this is incredibly fast whenever it comes to raster engraving. Some more pros of a fiber laser. They don't require additional things like a cooler or air assist, though of course you are going to want some assisted ventilation because, you know, engraving metals puts off some nasty fumes. You don't need to have an air pump or a water cooler sitting there to keep this machine running. It's fairly self-enclosed. Another big bonus to this machine, unlike the other lasers, is they don't generally consider the laser source in these to be a consumable. That's a huge bonus. It means you're probably not going to be buying a new laser source in 2 or 3 years. On the downsides, the price can be fairly prohibitive. They've come down considerably in the last few years. This one's just under $3,000, which puts it in the same price range as kind of a bottom of the line Glowforge, Muse, or Dremel desktop laser engraver, CO2 laser engraver. But they've previously been quite expensive, and if you start pricing them out, you'll see that that price at $3,000 for a machine like this rapidly goes up, you know, for more powerful machines or machines with more features. You could easily be looking at spending $15,000 to $20,000 for a nice fiber laser. Another pro of the fiber lasers, since they use that galvo head, usually if you're doing a vector cut or engrave, you get a nice preview on your material of the cut or engrave. It's really, really helpful for positioning and sizing and things like that, to be able to have that real-time preview on the material. That particular upside, though, is really just the benefit of using a galvo head. So if you manage to find a galvo-based CO2 laser or diode laser, those would probably have that same feature as well. The small work area on these is a downside as well. Even though you see this large plate here, this machine specifically can only do about a 6-inch by 6-inch area. You can increase that area by using different lenses or having a more powerful machine, but generally speaking, these desktop fiber lasers will have smaller working areas than a comparably priced CO2 laser would. Okay, this is going to be fun. I'm going to show you all three of them, raster engraving an image at the same time with time comparisons, so you can see what I mean by one's faster than the other. All right, now let's look at a cut. Now I'm not including the fiber laser in this because it responds so differently to different materials than the other two that it just really didn't make sense to me. So here are the diode laser and the CO2 laser cutting something. So let's look at all the details side by side. Let's start with the price. A diode laser is going to run you $200 to $1,000. Now there are some more expensive, but personally I think that at that point, you should just be considering a CO2 laser. But CO2 lasers are up next. You can get a CO2 laser for $500, and from there they go up to like $10,000 or more. And then fiber. Fiber is going to be the most expensive in that group, starting at about $3,000 and going up from there. Next we have power. Now like I said before, power is not really, I'm including it because I'll get complaints if I don't, but power is not directly comparable across the board. For example, the diodes have, they're advertised as like 50-watt machines, but they're actually 15-watt, and then when you look at them internally, that's actually multiple 6-watt diodes being combined. So you can get it like a 6 to 15-watt diode laser. CO2 lasers will run you 40 watts to 150 watts in that price range. And fiber lasers will run you 20 watts to 60 watts in the $3,000 to $8,000 price range. Up next is the size. Diode lasers I've got listed as a medium size because they can have a decent, footprint on the ground. However, I do have an asterisk here because they do have the added benefit of being able to move around. So you could do that cool trick with light burn where you do something giant. So they could have a massive size. They could have the biggest size, theoretically, of all of these if you use light burn. Up next is CO2. CO2 I've got listed as medium to large cutting area because, your smallest one is a machine like a K40 that's a sheet of paper, but once you get up into the big 150-watt machines, they can be rather large, several feet across in both directions. And fiber lasers have a small cutting area. Really, people aren't using these fiber engravers, these desktop fiber engravers for large things. So most of the time you're paying for features and power more than size. Of course, there are industrial fiber lasers that are massive, the size of warehouses that cut through sheets of steel, but that's a different topic altogether. All right, so let's get into what their specialities are. Diodes are cheap and portable, especially if you don't spend a ridiculous amount of money on one. They're cheap and portable. That's really cool. CO2 lasers are comparatively cheap and powerful. You can get for $500 a 40-watt CO2 laser, and you can also spend $500 on a 15-watt diode laser. So they're fairly cheap and powerful. And fiber lasers, of course, are able to engrave in metal. That's their main selling point, and that's enough. That's pretty awesome. Thank you so much for joining us. I hope you learned something today, and I hope this was useful. Leave a comment down below if you've got more feedback and more differences to point out between the types of lasers. And a huge thank you to Lightburn for sponsoring this video. Be sure to check them out as well. I'll see you on the next video.